So the demo gods have already frowned upon me in that they gave me a cold this morning. So I'm gonna make this as fast as possible, but still informative, so you don't have to listen to my scratchy voice for very long. So everyone, thank you for showing up to the second Stategraph launch day. These used to be demo days, but then we started actually shipping things. So now they're launch days. It's going to be tough to beat this one, I think, but we are committed to delivering as much awesome product as possible, as fast as possible. Now, today's launch is about Stategraph Velocity, and the goal of Stategraph Velocity is to allow you to plan and apply faster, and also plan and apply in parallel. And what we mean by in parallel is if you have multiple people modifying resources that live in the same state file, in Terraform, they would have to be serialized. So person A would have to go before person B because the state is written in red as one big unit. In Stategraph Velocity, as long as those people are not modifying overlapping resources, they can plan and apply in parallel. So they no longer have to be serialized relative to each other's work. The agenda today is really just a demo. We've been talking about this for months and we're here. So we're not going to show too much other than the actual thing we want to show off. But just real quick first, the goals of Stategraph are to provide a database, to bring database abstractions to your infrastructure. And with that, we want to be able to provide insights into your infrastructure and make plans and applies blazingly fast by leveraging the graph of the state. And all of this comes from us actually understanding your state representation and being able to store it in a database and have fine-grained access to the individual parts of it. In developing Stategraph, we've also realized there's a third goal, and that is to manage all of your infrastructure as one unit. And so what does that actually mean? It means that if you have infrastructure, even if it is broken up, its Terraform representation is broken up across multiple state files. If that infrastructure has connections between it, you should be able to operate on the whole thing as if it's one change you're doing in one unit and not have to care that you have to go to state A to make this change or state B to make that change. So with the demo here, we're going to show fast plan apply as well as parallel apply, and then what we're calling cross-state transactions. So remember, we're trying to bring these database abstractions to your infrastructure, and the core to that is actually transactions. So when you make a change to your infrastructure, you're going to create a transaction, put the changes in it, and then previewing that transaction as a plan and committing that transaction as an apply. And then the last one is to show an extreme example of what we're able to do with Stategraph. So first, let me just make a change to a file here. Loading. Well, that's a 100 meg Terraform file. I hope it loads. Took a second here. And this has all sorts of crazy names in it because a design partner gave it to us and they needed to anonymize all of it. But this is an actual root module from a design partner. So let's make this change. And we'll let that plan in the background while we go do something else. So the first thing I want to show you is that Stategraph can do applies faster. So as an example, I have this root module, which has what we're going to call 3 islands in it. So we have A, which we're going to say it's team A's resources. And by an island, we mean that all the resources in here only reference each other. They don't reference resources outside of this island. And we have B, which is the same thing. They only reference resources inside of their own island. And then we have this final one, which is just meant to simulate very slow resources. So we use a data source here to sleep for 60 seconds, and then we reference that data source in a resource. Now, you'll notice we're not using AWS resources. We're just using Terraform data, and you'll see some other things with null resources. And the reason we're doing that is because, one, we're going to be doing some planning and applying, and we don't want to wait for however long it'll take for AWS to do something. Two, we're fearful of the demo gods, and AWS had an outage not too long ago, so we didn't want that to impact us. And then three, we wanted to make this sort of a clean room example where we take away all the other factors that could be impacting what you're about to see, and really just show you what the difference Stategraph is making relative to vanilla Terraform. So if we take this Terraform file, and I've already done it because it takes a little bit, but if we apply it in vanilla Terraform, it takes around 60 seconds, which is what you'd expect because we have that sleep there. Also, if you just plan it again with refresh off, you'll see it also takes around 60 seconds. So this is a no-op change, but because it has to run that data source again, it's left asleep for a while. And you can see at the tail end here, you can see how long it took for Stategraph to do the initial plan of that. So it took around 60 seconds, a bit longer actually. And this is just putting the initial resources on the first run into the Stategraph database. So it has to run everything in that case. And then the apply took around 15 seconds. Now, but once it's in there, what can we do? So let's go into our demo. And let's simulate somebody from team A wanting to modify one of their resources. And again, that's going to be modifying a resource that doesn't interact with any of the resources in this file. So let's just change that to 4 and do a Stategraph run, a plan. Now, the key to how Stategraph works is that it operates on the subgraph of the state that you're operating on. So it knows the connection between every resource inside of your state. And that means that if you do an operation that doesn't impact other resources, those resources aren't included in Stategraph performing a plan or an apply. So Terraform on a no-op took 60 seconds. You can see in this case, Stategraph took 15 seconds. And we can see that our Team A resources have been modified. Now, let's simulate someone from Team B also wanting to make a change to the infrastructure. So I'm someone from Team B. I'm going to clone the repository, go in there, and I'm going to make changes to just my resources. So we go find something from Team B and change that to 2, let's say. And again, let's plan that. And again, this is operating on the subgraph. And so Team A and Team B, those islands don't include any of the slow resources. So we should expect this to take around 15 seconds as well. And we see that it only has changes to Team B's resources. Now, we have planned Team A and Team B, and they are modifying the same state. So let's see if we can apply them at the same time. Now, in Terraform, one of these would fail, right? So a state lock would be taken out, and one of them is going to win, and the other one won't be able to acquire the lock and just fail. And in Stategraph, since we are operating on state as just rows in a database, if you have a transaction in your database where you modify rows A and B, and then another transaction that does C and D, those two transactions can commit at the same time. So, and that's exactly what we see here. Team A and Team B, these changes could be applied at the same time because they are not modifying overlapping resources. despite being in the same state. So we've shown that transactions can, or plans can run faster because we're only going to operate on those resources modified by the impacted by the subgraph there. We can also, for non-overlapping changes, we can apply those at the same time because the transaction. For no prompt on apply, in this case, it's just since we've created a file for the plan, then we're just applying the file. Now, another common case in infrastructure is that if you have large infrastructure, the recommendation is to split it over multiple root module and multiple state files. But infrastructure in general is actually connected. So maybe not everything is connected to everything, but resources in one state file are probably consumed by those resources in another state file, because that's just what infrastructure is. And we might split our infrastructure over multiple states for reasons. Some of them might just be to make it more understandable. All those resources associated with one thing are in one state file and with another in another. But it could also just be because our infrastructure is too large. So this is the best practice. So in this case, we're going to show that example under Stategraph as well. So we have an example here, which is some state file has an HTTP proxy port and it exposes it through an output. And then we have another state, which is going to consume that state through a Terraform remote state data source. And imagine maybe this is like the security team or something like that, and they want to open certain firewall ports. They want to have some firewall rules depending on that port. So we create a min and a max, which is just plus or minus 10, and we create outputs from that. So doing this in Stategraph is not really that different from Terraform to start with. We do our plan, and we see that we're going to make our HTTP proxy port. We apply it, we get the output for it, and it's 8080. Then in the other root module that consumes it, we plan that as well. But something a little bit different happens here. And in the plan, you can see that Stategraph has detected that another state is involved in the operation on this root module. So we get a little legend that is state 0 is from the first root module, and state 1 is from the other root module. These are just cross-state root module 1 and 2. These are names that I gave it. And then in the output, you can see that we're going to perform these operations. We're going to create a new firewall rule, min and max. These will be in state 1. And you can also see that we have references to the input state, state 0. So we know that we're consuming the output from the original state, and this state will produce new ones. And then we apply that, and again, we see that this is a multi-state operation. We have created these in state 1, and then our outputs here are in the source state and then the new state. So we can see the connection there. But let's say you have this setup, and you have just joined the company, and somebody says, hey, we actually want to modify the port that the HTTP proxy runs on. So you find that in your root module, you go to the code, and you open that up, and you make the change. So let's say it's going to be 80. So I'm making a change here in the root module that defines the HTTP proxy. And now let's plan that. And again, here we're operating on the subgraph of these changes. We're finding everything impacted by it. And what's interesting here is Stategraph has detected that this is a multi-state operation. So we didn't make a change in the consumer. We made a change in the producer, but Stategraph understands that relationship, and it says, okay, in state 0, you've modified the HTTP proxy port to be 80. I know that there's other states here that consume that, so I'm going to include those in the plan. And when you do an apply, also apply those in those other states. And now we can see the complete blast radius of a change we're making. We no longer have to use something like TerraGrunt or even the tools that we've developed in our orchestrator where you have to define these relationships. The actual Terraform code defines the relationship between these state files, and Stategraph knows how to follow them. And now in a single plan operation, you can see the complete and true blast radius of a change you're making. We're not mocking anything in here. We are actually running a single plan and putting all of these resources in that plan in order for you to see what the actual blast radius would be. Imagine if this was a real change where you made the change to HTTP proxy port. You didn't realize you had to make a change to a firewall as well. And now you have an outage because your firewall rules no longer correspond to the actual ports that you're operating on. And now your traffic is blocked. It might take a while to actually figure out what's going on there. Okay, so for the last one, we had I mentioned there's a file from a design partner. It is anonymized, so it's a bit hard to read, but the important parts are that the Terraform file alone is around 100 megs. The produced state file is around 800 megs. On my laptop, Stategraph running on my laptop, I loaded this into the Stategraph database. It took around 6 minutes to load the entire thing. And then I made a small change to it. Again, all this running on my laptop to see how long it would take. It took 71 seconds to plan that change. And then I did another one where I undid the change and I wanted to see how long that would take. Took 97 seconds to detect that there was no change there. There's a little bit of variance because it's running on my laptop. This is a 100 meg root module with an 800 meg state file on my laptop. It took between a minute and a half to do these operations on it. So for any skeptics out there around how long does this take on Terraform, well, we ran this. And doing a no-op alone on a big, beefy cloud machine took almost 3 hours. So Stategraph is not just doing like refresh faults or dash target or any tricks like that. It's actually providing like a fundamentally different way to operate on your Terraform resources in a totally backwards compatible way. It consumes the same exact code that you've written before. It operates on it inside the database. It operates on the subgraph of it. And it can handle massive states and massive infrastructure hundreds of times faster than the Terraform CLI can. Any questions?
Malcolm, I think there's some questions in the chat.
Let's see. Okay, from Ozzy, how does Stategraph handle this parallel apply if parallel applies do have some overlap? So in the case of overlap, it looks at the subgraph that the apply is going to operate on. So you can do the plans in parallel still, but once one of them, so one of those will win the apply race, and the other one will see that the other transaction is operating on overlapping resources, and it'll tell you, the user, that there's a conflict and you have to replan and reapply. And there's no race condition there as well. It's using the database to coordinate all that in the backend. Let's see. Another question, can I plan the consuming state for even applying the producing one and creating the output? Right now you have to do things in, so when you're first adding a root module that consumes the output of another root module, you have to apply the first root module first, and then you can plan and apply the second one. However, once you have both of those in there, and Stategraph understands the relationship between your root modules and state files, when you do a plan anywhere in your infrastructure that modifies other parts of the infrastructure, it will plan and apply those in one single plan and apply operation. And this is what we meant with the third goal of Stategraph, which is that you should be able to manage infrastructure as one unit. Like in the Terraform world, a state file is a file, and there's a hard boundary between two files on your computer, wherever they're stored. In Stategraph, the difference between a state file is a row in a database. So for Stategraph, it doesn't matter where any of these things are. It just consumes more rows when something's modifying something in an adjacent row. So it's a totally different paradigm in that way. Next question, to be sure to understand the concept, what is inside state 0 or state 1 is defined automatically by the tool. We must think which resource should be in which state. So in this case, state 0 and state 1, those names will probably change in the future. They're just identifiers we gave, so you can look in the plan output to understand which state particular resource and that output is part of, because now a plan is showing you resources across multiple state files. So you need some way to recognize that, for example, the database resource, the two database resources that you have in state 0 and state 1 are actually different. There's still some work to be done to figure out how to best communicate that to the user. But in our example, state 0 was all of the contents of that first root module that we looked at. And state 1 was all the contents of that second root module that we looked at. I hope that answers your question. I love the showcase here. Seamless migration options and high-value DX integrations are going to be paramount to snag TF holdouts. It's non-trivial amount of risk in such a migration. How does Stategraph view OpenTofu versus Terraform history? I mean, we don't have like a particularly strong opinion on OpenTofu versus Terraform history in this case. We're founding members of OpenTofu, so we believe in the foundation layer there of OpenTofu, and Terraform should be open source. We are building on those legacies. So we very much appreciate that both of these exist and the change that they've done. And they allow us to do what we're doing here. In terms of, just to go back to something you said around DX integrations and get TF holdouts, Stategraph is easy to put your state into. You just do an import operation, and it's easy to get your state out of. You can just use it as, you can do a Terraform state migration. So the ability to try Stategraph to test it out and see if it works for you is very straightforward, and you can do it in a shadow mode as well. So if you're curious, you can always start testing it out without committing to it. Next question, what if somebody does changes manually outside of Terraform? So Stategraph uses the changes you've actually made in your repo to understand what has changed and what to run. But it's always possible, for example, that you have done ClickOps or something like that, and Stategraph won't see that immediately because we aren't refreshing all of the resources all the time, of course. So there's a few options there. One is that Stategraph has a force parameter where you can specify a pattern for which resources you want to run, regardless of whether Stategraph thinks there's actually a change there. And you can also set, for example, like this resource needs to run at least once a week. So if it has changed, it'll get caught on the next time that it has to run on its weekly schedule. You can set other schedules as well. So you have a few options there. You can either force it or set, like, we want resources to be updated at least on some schedule. Hi, what is the database backend storing the state? It's just Postgres. Can I just get some clarification on where the state would be stored, as it would be stored in the database hosted by you? So Stategraph, good question, Daniel. So Stategraph right now is focusing entirely on self-hosted installations. We understand that state is really sensitive. It's really important for a lot of people. And to be honest, a lot of our initial partners are in highly regulated industries, so they can't actually use a SaaS anyways. So currently we don't provide a SaaS. So all of the state is stored on whatever infrastructure you've decided to set Stategraph up on. So we would see none of that. Regarding the 100 MB state file, just to clarify, it was a 100 meg Terraform file. The state file was 800 megs. What exactly does Stategraph do differently than Terraform here? You said you didn't disable the refresh, so you're refreshing 100 megs worth. This was 9 seconds. No, so we only operate on the subgraph of what has changed. So we're not refreshing all of those 800 megs worth of state. We are only refreshing the bits that the subgraph operation tells us have changed based on the operation you've done. So conceptually, you should think about this as drift detection, which is validating if state actually reflects what our code says, is a different operation than I want to make a change based on a code change. So when you're operating at scale, you already can't, or like this type of scale, for example, you already can't be doing refreshes every time anyways, because you'll never accomplish anything. So that design partner that gave us that 100 meg file, they're already operating with refresh turned off, and they have a nightly job which does a refresh to update the latest and then reset the state. And so in this case, Stategraph is really optimizing this day-to-day operation where I'm making a change and I just want to use whatever the state looks like now in order to make that change. How does Stategraph speed up Terraform refresh if random resources are being modified manually? We mentioned that above. Is it possible to define pulp access on resource level in the various states? A team has read access. Yes, so when it comes to managing access to your resources, Stategraph is entirely API first. So all of the operations I've shown you are actually using the API to create transactions, push the operations to them, and also so it's all API first, and we have a layer in front that is consuming HCL and turning it into Stategraph API calls. So in that sense, in order to do anything, you need an API key. So not just anyone can go and start planning and applying changes. So that means we will have fine-grained control over all of these operations. Right now, it's just plan and apply, but keys can also have like which resources they can have access to and which operations they can do on those resources. So the answer is yes. Since we're so API first, we can do all this fine-grained access control inside of the Stategraph server. We can also do other things as well because all operations are going through the server. That means you have a centralized location for things like running policy, running cost estimate, all these things. So somebody can actually start using modifying infrastructure on their laptop, and you are still guaranteed that even though they've done it in sort of this unsanctioned environment, they can't make a change that violates any of the guardrails that you've established. Next question, is Stategraph a backend we can use in normal Terraform? No, so Stategraph has a Terraform backend mode where yes, you can use it, but you won't get any of the benefits we talked about here. We need to do a lot more operations. We need to have a lot more control over what's going on to get the benefits we've talked about here. The Stategraph Terraform backend is just a standard HTTP backend for Terraform. It is not a complete replacement for Terraform. We are still using all of your, the providers that Terraform and Tofu have access to. So we haven't modified that, but conceptually, you should think about it as a compatible third implementation. Question, but who defines it? State 0 and state 1? I don't get my answer. So state 0 is a name that we have made up to show you in the legend. Let me see. I'll show it. So I have a state that I've created which I named cross-state root module 1. I have another state which I've created, which I've named cross-state root module 2. And we're giving them just arbitrary names here based on the order they are in the database. And so state 0 corresponds to the state that HTTP proxy port lives in. And state 1 corresponds to the state that the firewall rule port resource lives in. So I hope that answers your question. These are all states that you've created through the Stategraph state create or Stategraph import operations. And we're just giving them arbitrary names. This name here is a name that you will have given your state file. So you would have given this a reasonable name. Nice name. Well, thank you. Any plans to have integrations with HTTP Terraform and Terraform Enterprise? We would love to have integrations with HTTP Terraform and Terraform Enterprise. I don't have any specifics to give you on that currently. So if we have a single root module, Stategraph is not going to split anything. Well, it depends what you mean by split. Even inside of the first example I showed, where we had a slow resource and fast resources, and we modified fast resources and everything ran quicker, that is because inside of a root module, Stategraph is only operating on those resources inside that module that change impacts. So even inside of a single root module, you'll only operate on the subportion that is relevant to the change that you're making. So you will split inside of a root module, if that's what I understand split means in your question. Is it open source to try out? It is not open source, but we have a free tier. And actually that leads me on to the next slide. If you are interested in getting access to Stategraph, here's the link, and here's a QR code that you can scan that goes to that link. Hi, I've tried self-hosted options of Stategraph just now, and I tried plan. Jump into our Slack so we can have a back and forth on exactly what you're doing. We'll see what issue you're running into. Our Slack you can get through stategraph.com. And we are available to, when you want to try things out, to help you go through that process. Let's see. I don't know if I've kept up with all the questions here.
I think you're doing right. Maybe talk about importing and exporting, going back and forth between Stategraph.
So to get into Stategraph, the easiest way is there's a Stategraph import command, and you run it inside of your root module where you have all of your Terraform code, and then you also give it the path to a downloaded copy of your state file, and it loads everything up into Stategraph. And it needs to do it this way because we want access. Stategraph needs access to the code to understand the relationship via the code, and also the state file to understand what things look like. Once you're there, getting out of Stategraph is as simple as setting Stategraph up as your Terraform state backend, and then just doing a backend migration. Compatibility with TF versions. So we haven't hit a version we're not compatible with. So try out any version you can. That's all the questions I see. Thank you everyone for joining. Really appreciate it. Definitely reach out to us in our Slack. Even if you want to tell us that you hate it, we want to hear everything. We want to hear why, so we can make it better. But thank you very much. The team's been working super hard on this for the last, I don't even know how long. And everyone has been really encouraging and really supportive. So thank you very much, everyone, for coming.